Hey again, guys, and welcome back. Not that long ago, in a mailbag video, I got this device here, which is just basically a, I guess, an LED panel it's got a little bit of frosted plastic on here. And I figured we'd take a closer look at this because this device came with something that scares me, a Chinesium driver of unknown origins. So if you want to see this thing lit, you can plug this in. There we go. It's got a nice soft start, and the light is pretty good. The spread, I'm just being careful here. This is not grounded. It's only a two wire device, as you can see here. So the spread is nice. It's a warm white color. I can tell that a little bit more light comes off on the corners here, but overall it's pretty good. But the thing about LEDs is that they're DC. This plugs into the wall in like AC. So I figure this driver here can probably be replaced by like a wall wart or something if we figure out how this thing works. I think a good first step is to tear this apart and see what's going on. Now, this is just powered by a little barrel jack here, which is nice because it actually has a locking feature on it. But other than that, this looks pretty simple. There's a few Phillips screws here, which we can easily remove. Not sure what we're going to find inside, but what I'm guessing is there's just going to be like LED tape, I guess, going around the edge here. And if so, that might be a good thing because 12-volt power supplies, 12-volt power adapters maybe, they're easy to find. You can find them in thrift stores. Maybe you have your own electronics that stopped working and you kept the wall wart. You might already have something that you can use to power this without using a suspicious Chinese power supply of dubious origins. I think this cost me about 18 bucks Canadian on eBay, so it wasn't all that bad. Okay, so we've got a grommet. Oh, the grommet slides out. It's good to know. Come on out. There we go. Okay. Oh, this has little foam pads here just to, I guess, tension everything down in one direction. Got the wires here. And I guess I'm going to have to take this little panel off here. This looks like a reflector. Don't put any fingerprints on it. Yeah, just a piece of plastic, white. That looks like it's frosted plastic. Peel that out. Yeah, so this is the diffusion layer. So it has all sorts of weird patterns on it because the light comes in on the side and attempts to diffuse everything forward. Here are our LEDs all around the circumference or the outside of this. Here is another diffusion panel. This is a milky in color. It's not particularly translucent, and that's just to hide all the hot spots once more. And then all our LED strips. It's just a bunch of tiny LEDs all around, and those corners seem brighter because the corners tend to have two LEDs, it looks, pointed in the same direction. So that's pretty cool. There's some numbers on the LED strip, but yeah, I don't really see what it says. It looks as though the LEDs might be in a parallel, 5 parallel. Don't know if I can do this here. Don't know if you're in focus there, but it looks like there are tracks here. Looks like 1, 2, 3, a little solder ball there. 4 and maybe 5 are in parallel. And then it goes on to the next string. I'm not 100% sure how this works, but we can certainly check the voltage by hooking this up to a multimeter. Before that, it might be a good idea to put it back together. So here go the layers. That's the bottom diffusion layer. Here's the LED diffusion layer. Got to be careful here. Don't want to smash these LEDs too hard. I don't think this is glass. I do believe this is all plastic. Here's our reflector. Make sure everything's pointed in the same direction. There we go. Put my back panel on. This is metal. And I think this is also metal, but the rest is all plastic. I'm going to put the grommet back in there. Trying my best to get this in. Oh, it looks like it goes in sideways and then turns. It's good to know. And funny, they use these little flathead screws instead of button head screws. These screws that are countersunk in a bit instead of button heads, which would have been clearly better for this, but that's okay. They use whatever's cheap. I'm not going to be too fussy about screws, especially for the $18 or so I paid for this, with a driver and everything, although I don't think I'll be using the driver. And they do make these now in much, much bigger panels, but here in Canada, a 2-foot by 4-foot panel, I believe, is about $70 to $100. If it could be run on 12 volts, that might be worth it. But other than that, I don't like running that much current through a driver that is uncertified. Okay, so let me get the driver and we can connect this up and take a look. Alright, got everything plugged in. Now I'm going to open this case, which I've already cracked the last time I've been in here. I just opened it up in the mailbag. Crack the case wide open. Alright. So this is the scariest part because I want to get onto these 2 terminals here. So I want to get to this and read the DC output, which might be a little sketchy, but it looks like it's tied to these 2 outer connections here. So what I can do is I can use something like Kapton tape, or in this case counterfeit Kapton tape. Tape this all together and attempt to insulate it so I won't get any fingers on there. There we go. Gives me a safe place to put my fingers. Actually move this off to the side a little bit, and I will stick this down to the bench so it doesn't go wandering around. One there and one there. There we go. Probably put an extra little layer of security. There we go. Just so I don't go touching the live and neutral. Okay, so I'm going to be probing right over here. So I'm going to set this up into DC volts. There we go. Probably put this where you guys can see. This maybe, do you need the light? That did all of nothing. Okay, let me just move it like this then. There we go. Can you see that? I think you can see that. Okay. And now I'm just going to plug in. Hopefully nothing explodes. There we go. I can see there's light coming from the cracks here. So this is definitely lit. Now I'm going to probe very carefully. If you short anything, that would be bad. Ooh, this runs at 60 volts. So unfortunately, that is not going to be something we can easily do with a brick. There are boost converters that'll go up that high for sure, but I don't really have anything in hand. Yeah, that's unfortunate. 60 volts. I suppose for efficiency's sake they do that, because I'm sure now if you check the current going through these LEDs, it'll be a lot lower than if it were at 12 volts. Probably going to be in the order of several milliamps. Well, I think this is as far as it goes here. If I think of a solution, I'll let you guys know, but for now I think I'm stuck using this driver, which I'm not too happy about. Maybe I can find another driver somewhere. Oh well. Thanks for watching.